Welcome to our channel. Please like and subscribe. What is a black hole? What actually happens inside? Imagine this. You're floating in space, silent, weightless, staring into the darkest thing you've ever seen. No light, no reflection, just a void, so powerful that not even light can escape it. A black hole. But here's the real question. What actually happens if you go inside? Do you get crushed instantly? Do you disappear forever? Or is there something stranger, something we still don't fully understand? Today, we're going to slow this down, step by step, from the edge to the inside to the unknown. Because black holes are not just dark. They are some of the most extreme and mysterious objects in the entire universe. Let's begin. 1. What exactly is a black hole? A black hole is not a hole in the way you might imagine. It's not empty. It's not a tunnel. It's actually a place where an enormous amount of mass is packed into an incredibly small space, usually formed when a massive star dies. When it runs out of fuel, it collapses under its own gravity, and if it's big enough, nothing can stop that collapse. It keeps shrinking, smaller, denser, until gravity becomes so strong that nothing can escape it, not even light. And that's what makes it a black hole. 2. The event horizon, the point of no return. Every black hole has a boundary, a limit, a line you cannot cross and come back from. This is called the event horizon. Once you pass it, escape becomes impossible. No matter how fast you go, no matter how powerful you are. Even light, the fastest thing in the universe, cannot get out. From the outside, anything that approaches the event horizon appears to slow down, almost like time itself is stretching, freezing. But from your perspective, if you were falling in, you wouldn't notice anything special. At that exact moment, you would just keep falling. 3. What you'd see as you approach. As you get closer, things start to change. Light bends. Stars behind the black hole stretch into arcs. The entire universe warps around it. This effect is called gravitational lensing. It's not just pulling objects, it's bending space itself. Imagine space like a fabric, and the black hole is pulling it down so deeply that everything nearby slides toward it. You're not just falling through space, you're falling through warped reality. 4. Spaghettification, the stretching effect. Now, this is where things get intense. As you get closer, Gravity becomes stronger and stronger and stronger, but not evenly. The part of your body closer to the black hole feels a much stronger pull than the part farther away. This difference stretches you, pulling you longer, thinner, like a strand of spaghetti. Scientists actually call this spaghettification. And yes, it's as extreme as it sounds. Your body wouldn't survive it, but the physics behind it is real. 5. Time behaves differently. Here's where it gets even stranger. Near a black hole, time slows down dramatically. To someone watching you from far away, you would appear to slow, almost freeze, right at the edge. But for you, time would feel normal. Seconds would pass like seconds, but outside, minutes, hours, even years could pass. Black holes don't just bend space, they bend time. 6. What happens inside? This is where science meets mystery, because beyond the event horizon, we cannot see, we cannot observe, we can only theorize. At the center of a black hole is something called a singularity, a point where density becomes infinite, where the laws of physics, as we know them, break down. No equations fully explain it. No experiment can recreate it. It's a place where our understanding simply stops. And that's what makes it so fascinating. 7. Do you get destroyed instantly? It depends. If the black hole is small, yes, the forces are so extreme you'd be torn apart quickly, but if it's a supermassive black hole, like the ones at the center of galaxies, something surprising happens. The gravitational pull at the event horizon is actually much weaker. You could cross it without immediately feeling anything. You wouldn't be crushed instantly. You would just keep falling deeper and deeper with no way back. That's somehow even more unsettling. 8. Information paradox. Here's a question that has puzzled scientists for decades. What happens to the information of everything that falls into a black hole? Does it disappear forever? That would break the laws of physics, because information should never be destroyed. This is known as the black hole information paradox. And even today, we don't have a complete answer. Some theories suggest the information is preserved on the surface. Others suggest it's somehow encoded in radiation. But the truth is, we're still figuring it out. 9. Hawking radiation. Black holes can evaporate. Black holes aren't completely black. They actually emit tiny amounts of radiation discovered by Stephen Hawking, over incredibly long periods of time. This radiation causes black holes to lose mass, shrink, and eventually disappear. Yes, even black holes don't last forever. 10. What we still don't know. Despite everything we've learned, black holes remain one of the biggest mysteries in the universe. We don't fully understand what happens at the singularity. We don't know how gravity and quantum physics truly connect. And we don't know what lies beyond. But that's what makes them so powerful. They challenge everything we think we know. They force us to question reality. And they remind us how much there is still to discover. So, what is a black hole? It's not just a cosmic object. It's a boundary between what we understand and what we don't. A place where space bends, time slows, and reality itself becomes uncertain. And maybe that's the most fascinating part. Not what we know, but what we're still trying to understand. Because somewhere out there, in the vast darkness of space, these invisible giants exist, silent, powerful, and still full of secrets, waiting to be uncovered.
That was excellent. Please like and subscribe for daily lessons. See you next time.